Welcome to part 10 of the CipherVibe Cloud Security Capabilities series. This episode explains data security and DSPM, why it matters, how the capability works, which mistakes weaken it, and how to build it in a measurable way. Data security posture management discovers where sensitive data resides, how it is classified, who can access it, and which controls protect it. Its purpose is to reduce material data exposure by connecting storage configuration, identity, activity, lineage, and business purpose. The key idea is that a security capability is more than a product feature or a collection of alerts. It combines people, process, technology, decision rights, evidence, and continuous improvement. We will examine its architecture, operating workflow, failure modes, defensive controls, implementation roadmap, and useful metrics. Coverage is not the same as effectiveness. A dashboard can show thousands of checks while the capability still fails because evidence is stale, ownership is missing, or remediation is never verified. The business outcome should be explicit. Teams need to know which loss scenarios the capability reduces, which systems are in scope, and which remaining risks require a conscious decision. To understand data security and DSPM, start with its architecture and vocabulary. The capability should create a traceable chain from source evidence to a security decision and then to an accountable action. First, discovery identifies structured and unstructured stores, snapshots, replicas, analytics platforms, object storage, databases, and collaboration systems. Second, classification uses patterns, dictionaries, metadata, machine learning, and business labels to identify regulated or confidential content. Third, effective access analysis evaluates users, groups, roles, service identities, public links, resource policies, and cross-account trust. Fourth, data lineage and activity show where information came from, where it moves, how it is transformed, and whether access is expected. These concepts need shared identity, timestamps, provenance, ownership, and access control. Every summarized risk should link back to its source evidence and disclose missing information. A sound architecture separates collection, normalization, analysis, policy, workflow, and presentation. Teams can then test freshness, identity resolution, policy results, owner routing, and closure independently. Design for degraded conditions. Providers impose rate limits, schemas change, credentials expire, and events arrive late. A professional capability reports uncertainty and health instead of presenting incomplete information as fact. Trust boundaries deserve equal attention. Identify where data crosses accounts, tenants, regions, vendors, privilege levels, and administrative domains, then apply authentication, authorization, validation, encryption, and audit controls at those boundaries. A useful operating model for data security and DSPM follows a repeatable evidence lifecycle. First, inventory data stores and map them to owners, applications, jurisdictions, retention rules, and business purpose. Second, scan representative content using privacy-preserving methods and validate classification quality with data owners. Third, prioritize stores combining sensitive content with public exposure, excessive access, weak encryption, or suspicious activity. Fourth, reduce exposure through access redesign, tokenization, encryption, retention enforcement, isolation, and secure deletion. Fifth, continuously monitor new stores, permission changes, data movement, policy drift, and exception expiry. The workflow does not end when a ticket closes or an API returns success. Security closure requires fresh evidence showing that the risky condition is gone and does not immediately recur. Ownership should be established before urgent findings arrive using service catalogs, business applications, on-call schedules, and escalation paths. Prioritization should explain the influence of exploitation, reachability, privilege, data, business criticality, compensating controls, and confidence. Repeated findings should drive changes to secure templates, defaults, libraries, identity patterns, and architecture standards. Define escalation points for missing owners, disputed priority, failed changes, and evidence that suggests active compromise. Those conditions should move into incident or risk governance rather than remaining indefinitely in a routine queue. The fastest way to evaluate data security and DSPM is to study how the capability can fail. First, classification without validation creates false positives that overwhelm data owners. Second, security scanners may themselves create privacy risk by copying sensitive content into logs or external services. Third, a private storage endpoint can still be broadly accessible through identity and service relationships. Fourth, backups, snapshots, exports, and non-production copies often retain sensitive data longer than primary systems. Fifth, deleting data without legal, recovery, and application context can violate obligations or break operations. These failures share a pattern. A local measure looks successful while the full outcome is weak. A connector, scanner, or repair can report success while coverage, exploitability, or recurrence remains unresolved. Measure whether the program improves important coverage, shortens exposure time, removes attack paths, and prevents recurrence, not how many alerts it produces. Exceptions need a reason, owner, compensating controls, approval, and expiry. Automation should reflect confidence, reversibility, blast radius, and business impact. Test both through controlled failure exercises. Correlate weaknesses instead of reviewing them separately. A moderate configuration issue, broad identity grant, exposed service, and sensitive data store may combine into a severe path even when no individual alert looks critical. A dependable data security and DSPM program uses defense in depth. No single scanner, policy, gateway, or agent should be expected to carry the entire outcome. First, use scoped read access, regional processing, sampling, encryption, minimization, and strict retention for scan evidence. Second, maintain classification policies with owner validation, confidence thresholds, and documented business semantics. Third, correlate data sensitivity with effective access, exposure, vulnerability, runtime, and activity. Fourth, enforce encryption, key separation, private connectivity, least privilege, retention, and approved sharing. Fifth, create response playbooks for public exposure, unusual access, mass download, and suspected exfiltration. Control design should include preventive, detective, responsive, and recovery layers. Together, they establish safe defaults, identify drift, govern containment, and restore service. Least privilege applies to connectors, agents, orchestration identities, data stores, and administrators. Scope, separate, monitor, rotate, and test their access. Every control needs an owner and test strategy. Validate it with representative assets, negative cases, simulated attacks, provider failures, and rollback exercises. Integrate controls with engineering through clear pull requests, owner routing, reusable fixes, documented standards, and fast feedback. Preserve an evidence trail from detection through decision, approval, change, and verification. That lineage supports investigations, audits, lessons learned, and fair performance measurement without forcing teams to reconstruct history from separate systems. A practical implementation roadmap for data security and DSPM should build trust before scale. First, start with crown jewel data domains and the highest risk cloud storage services. Second, validate discovery and classification with data owners before scaling coverage. Third, add entitlement and activity analysis to distinguish theoretical from active exposure. Fourth, automate safe fixes for public access, stale sharing, and retention violations with approvals. Fifth, integrate DSPM evidence into incident response, privacy operations, architecture, and executive risk reporting. The roadmap is incremental because a focused production scope lets teams validate evidence, ownership, workflow, and control safety before scaling. Useful measures include sensitive store coverage, public sensitive data exposure age, excessive access rate, classification precision, and unowned data store count. Give every metric a precise definition, data source, owner, and known limitation. Pair lagging indicators such as exposure age with leading indicators such as coverage, control health, exception expiry, and secure template adoption. Maturity means the organization can discover important risk, explain it, assign it, act safely, verify the result, and learn from recurrence. Review the roadmap quarterly. Changes in architecture, threat activity, regulation, business strategy, and provider services can alter both priorities and assumptions. Retire metrics and controls that no longer guide useful decisions. For more cybersecurity market intelligence, research, and educational briefings, visit CipherVibe.com. CipherVibe is operated by Cloudsectech LLC. This video is general education, not legal, compliance, financial, or incident response advice. Never access or test systems without explicit written authorization.